Ciao Andrea, good morning and good afternoon to everyone. And thank you for your participation in this GEM International webinar.
Hello everyone.
With me, Andrea Spolaor, who will help me to lead this webinar. Andrea, if you are agree, let's wait a few moments before starting our presentation to allow everyone to connect.
Yeah, people stay connected. Yeah, just a few information for you. That is, you cannot talk with us, but you can write. So you can use your chat. Sorry, it's called in English is
Q&A, question and answer.
Question and answer, exactly box. You can write your question there. We'll try with Massimo to give an answer live, if it's possible. If not, we'll write you later. And but there is no, of course, no stupid question. You can make any question to us, and we'll try to give you best overview. Of course, we have the topic today is intrinsically safe isolators and the process and application aspects, which is our core business company. And but of course, there are no details. We have seen a lot of questions during your say when you register into the webinar, a lot of different questions, specific questions. Of course, we cannot go in such detail. We try to give you a picture of the application, and any other question, maybe we can say leave it to a later session. Maybe you can write to us, say, and we keep the time to check the topic and answer it. Okay, Massimo, we can go ahead.
Okay, well, Andrea, I think we can start now. Let me give some information on today's speaker. As already mentioned, I have with me Andrea Spolar. Andrea is a global account manager at GMI. He has over 20 years of experience in the machine process automation market. His main area of activity is in industrial control process in hazardous area application involving signal conditioner, remote control, and bus interfaces. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. Andrea is a functional safety engineer from 2016. And I, Massimo Pagani, product specialist at GEM International. I've been employed at GMI for about 14 years. My main role is to support our R&D department for new products development and our sales department to promote the technical part of our products. I'm a functional safety engineer since 2020. Well, some information about our company. GEM International is an Italian company born from the experience of Elcon Instrument and for over 25 years has been design, engineering, and manufacturing a complete range of seal-certified intrinsic safety devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in various industrial sectors such as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. All our products are tested one by one and must conform to the strictest worldwide specification. GMI is located around the world with over 200 people who make up our staff distributed on all continents. We have product stock distributed in our main branches in Dubai, Singapore, Houston, and in the other part of the world. GMI has always been perceptive to market demands. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activity is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the products. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in high automated process. The goal of our company is to supply and guarantee innovative and high quality products. All our products are tested one by one and must conform to the strictest worldwide specification. Our products are tested and certified by over 15 independent UV agencies and laboratories, and they have a certification available for different market applications: Europe, America, Korea, China, India, and so on. According to the new ESC 61508, the seal certification of the products is no longer valid if not supported by the systematic capability design certification. For this reason, all our products are designed to adhere to the functional safety management, seal-free systematic capability certification. Additionally, over 10% of GMI employees are engaged in research and development of new technologies. Many of our resources are reinvested in research and development department. And last but not least, all of our products are covered by 5-year warranty. In the following slide, you can see the wide range of our products we deal with. Here we can see intrinsically safe barrier, safety relay, galvanic isolator, multiplex for temperature or digital sensor, seal-free power supply, termination board dedicated to the most popular PLC DCS system, R multiplexer, and so on. Furthermore, our company promotes advanced course of functional safety and safety in the X environments conducted by expert trainers. You can find all information about this course in our website. The last slide lists some of our main collaborators and customers distributed among system vendor, EPC, O&M, and end user. Well, Andrea, it's your turn now to introduce topic today.
Okay, thank you, Massimo. Sorry for this. There is a few slides that have been, of course, conducted by us because GMI is offering this webinar, so hope it is appreciated. Then we go to the topic, so intrinsically safe isolators. We divide by chapter the presentation, so will be first protection methods and intrinsic safety components, and then we go to IS isolator with applications, the line monitoring and so on, then the Modbus interface, and the conclusion. So let's go through the protection methods, and and we go with of course the first poll. So let me launch it. We want to go. Let me see what it is, because every time it's changing here in Zoom. What is the basic protection here? I'm launching, so you can vote it. So what is the basic protection principle for intrinsic safety? So can be isolation, can be mitigation, can be segregation, prevention, containment, and only one is correct. Let us discover if you know what is the principle which is at the base of in the intrinsic safety. So don't worry, write whatever you think, because it's with no name on this poll, so you is really you are free to write what you think, exactly you think. We have still a few seconds. Please go ahead with your vote, otherwise I will stop it. Yeah. Okay, no more answer. Let me stop it. I can share with you the results, and the results are, as you can see, most of you wrote isolation, some mitigation, some segregation, and some prevention, no containment. So the right answer, Massimo, is prevention. is a prevention. So let me show you why is prevention in the next slides. So how to power read protection, how to power read signal from field device studied in the hazardous area. So hazardous area is the topic. There are different principles. So there are segregation, of course, that is can be pressurization, can be all immersion, can be in increased safety, for instance. You have containment. So the segregation basically is something that, as the name said, close, let's say, put something like in the pressurization, higher the pressure inside the cabinet in order to prevent and to eliminate the risk of explosion. Containment is something that's in the middle. Let me the pointer here, so it's better. Here you have the middle here, which is just, of course, electronic, which is kept inside into the aluminum boxes, and in this case is really, in case of explosion, the explosive container is protected by this very strong enclosure. Then you have, of course, a prevention like intrinsic safety and intrinsic safety, where we are. So we prevent the intrinsic safety from having explosion in the field. So when the intrinsic safety was introduced in the market, has been, let's say, gained the fame that be the most flexible and the cost-effective solution, and SME standardized in different applications. So based on the ITEX directive, a device must be connected between the power source and the field device to make the system safe. So you see in the picture here, you have the IS apparatus, hazardous area, you have the control room, where you have probably also the DCS and the PLC, and but the system that protect the hazardous area, prevent, as we say, prevention, prevent the hazardous area problems are the barriers, or the intrinsically safe barriers, or just barriers. So basically you need to use this kind of solution that limit the energy into the hazardous area. Digital isolators. So the digital isolator are used to, let's say, to eliminate ground difference, for the ground difference of having caused some currents between the area, because there are in the different potential. So that is very important. So you isolated 2 different points digitally in order to prevent any current. So the isolator limits the power intrinsically safe circuit by restricting the amount of electrical energy. So really with the barriers, you limit the amount of electrical energy below the explosion, let's say the initial energy. So the energy you put in the field is below that level of energy, so you can avoid any spark. And the limit of energy probably is also depend on what you have in hazardous area. So you can have a different level of energy depending on the gas you have there. So an isolator is something that is designed as a standalone apparatus, but is a component of the IS circuit. So, of course, as I said, you have different initial energy, or different gases, or maybe also powder, you can have it, but of course, most of the time you have gases. And that gases, of course, I can use an isolator, which is used in, say, methane gas, because I have a methane, but cannot use an hydrogen, because hydrogen, the initial energy maybe is definitely lower. So I have to check if the device is suitable for the area I want to use it. And an isolator, an intrinsically safe, for intrinsically safety application, I have different application. You can have analog input, analog output, which is different, digital input, which is different from different output for digital output. You can have just a signal converter, chip amplifier, serial line converter, and then you have other application like load cell for weighing application, vibration that is often used in turbine motors to measure the vibrations, frequency input, temperature input, flammable liquid presence detector, and the smoke detector. So there are different applications. And an isolator nowadays have different features that are required. So you can have a very wide range for input-output signal because it's required by different standard. You can have a source of sink, current sink towards to the PLC and the PLC and DCS. So there are basically different cars that are powering, they are active analog input, and you must be, of course, passive. In this case, you are sync. Otherwise, you can have a solution where the card is passive and must be active, so source. So there are different applications, and nowadays the isolators have different functionality. You can have also solution where you have called two-wire signal, so a passive 4 to 20 milliamp signal, and that must be power over the isolator. Or maybe 4-wire where you have external power and you must just connect the 4 to 20 to let's say a unit, a barrier that in this case is passive. You can have some digital bus communication like Modbus, burnout fault detection. That is another important point, especially for sensor or temperature sensor. You need to get this kind of failure alert in case the wire will be broken. You have high accuracy or low accuracy, multiple isolation, so between input, output, and power supply. You have isolator with that can be configured for certain operating parameters, like alarm, for instance, like temperature range, can be like type of sensor, can have maybe thermocouples or RTDs, different topology. So you need in some cases, you need some configuration. And also there are, you need maybe the installation can be in DRAIL for the modules with the terminal blocks or a customized termination board for PLC makers. You want to connect that to the PLC. So this is just an overview for the first part, like a protection methods, intrinsic safety concept. Then we go to the isolators in details. Okay. So, and now we have another poll. Let me launch it again. What kind of solution do you apply? Yeah. So don't know if you use intrinsically safe isolator application, use a Zener barrier, still in the market, or PLCs with the integrated IS input. There are a lot, and nowadays more manufacturers are offering these solutions, or maybe you are using not intrinsically safe concept, but use mostly EXD or EXP or whatever. It can be no prevention, it can be containment, it can be segregation, as we have seen in the previous slides. Okay, so I don't want to share with you because it's just it's information for ourselves, but most of you are answering intrinsically safe isolator, which is important. Some of you Zener barrier, some of you system integrated with IS inputs, and other. Okay, thank you for answering. I'm gonna stop it, and I want to go directly to the next slides. So here we have say example, what is an analog input? So what is an analog input barrier or isolator? So it can be, we have seen, just talk about the possibility to have a 4-20 with different stand external power, the two-wire power, so power through the module. And output as well can be source or sink, let's say source in current or sink in current, or just source in volt. So you have different standards in one module. You have also the transmission for HHT, means heart, so heart transparency. Both for analog input with the two-wire, in this case not for four-wire, but there is a solution also for four-wire heart transmission. You have single channel, dual channel with a different complete isolation between the two circuits. Duplication also can be used. In the next slide, we show you how. Or you can have also CL2 on CL3 on the different unit. Basically, people asking for CL2, other people asking for CL3, so you have the solution. Two pictures, because one is an IS isolator, because you see the blue label, and one is non-IS, because it's green. So this is just an isolator for standard standard areas, and say non-hazardous area. Yeah, this is the same modules can be used for also for duplicating. So you want to use the same sensor, the same signal, and you want to send to two different apparatus, like a display, like a PLC, and so on. So you can have, in both cases, the solution sent to different apparatus. We have a solution of 4 channels, maybe. For some application, you can have, say, you can take advantage of having one unit instead of more units. So you limited space, you limited the cost, you gain in everything, because you're just wiring is just one power supply and so on. So you have a lot of potential interest in having 4 channel. These 4 channels are one-to-one, can be transferred to the output. You can have also a sort of configuration among the output. You can have it just repeat 4 times the first input. You can have an average of 2 inputs in the first output. So there are a lot of possibilities. You can have also the Modbus configuration, and of course a different typology of outputs. Then you have a triple alarm. So in some cases, the analog input has to be transferred to as 4-20, but also as alarm. Maybe you want to set some high alarm, low alarm, window alarm, whatever. That is also configurable. You can have, in this case, refer to first input, 1 analog output, and 2 contacts out. All of them offering also another point we have seen so far. This is a power bus connection. So the power bus can be extended to all the modules connected with. So just one power point connection. And also by this connector, there are multiple pins. You can have also common alarm fault. Okay, Massimo, maybe it's your turn for this slide.
Okay, thank you, Andrea. Let's see now how analog input devices can manage a field fault. A 420 milliamp signal allows us to standardize the measurement and using the Namur standard. We know that typically in the range between 3.6 milliamp and 21 milliamp, the measurement is valid and correct. The analog barriers allow us to read and mirror a signal that goes from 0 to a maximum of 26, 30 milliamps towards a system. In fact, the barrier has the main purpose of limiting the current in the loop to a non-dangerous level, which allows us not to generate a danger of explosion. This precise standard allows us to program our PLC, for example, to provide us with a line fault when the set threshold are exceeded, or in case of using devices with programmable alarm threshold on board, to provide a single fault contact or cumulative fault to a DCS system dedicated to the purpose. Well, now let's analyze how to obtain a correct system redundancy through trip amplifier devices. One of the typical applications which uses a redundant system with several devices, analog output in this case, is what we can see in the following slide, where 2 out of 3 redundant system of trip amplifier is used to activate our final element. This system and its redundant logic allow us to replace more complex systems composed of safety PLC, allowing us to save more engineering cost. Well, but let's see specifically. The 3 trip amplifier devices each have 2 alarm relay outputs with individually programmable threshold, and each of them is C2. By programming all the alarm threshold of the trip amplifier in the same way and connecting in the way we see in the slide, the relay output in such a way as to compose a matrix of contact, which allow us to obtain a seal-free level from a component certified seal2. To activate the final element, at least 2 of the 3 loops, sensor plus trip amplifier, must perform the same variable measurement in the field and correctly process the data. In fact, when at least 2 out of 3 sensors detect the same variable in the field, the related chip amplifier will activate their contacts, and consequently the final element is activated. But how it is work? If one of the elements in the field fails, or if one of the trip amplifier fails, the 2 out of 3 redundancy allow to maintain our safety function and process availability at high level. I repeat, this type of logic would be possible in another way only by using a PLC system with redundant cards, having a considerably higher cost. This system allows us to achieve an high seal-free level safety standard with high process availability. Well, Andrea, it's your turn for the analog output device.
Okay, thank you, Massimo. So this is a solution for analog output. So in this case, is available so single dual channel if required. You have a heart retransmission and of course, possibly having sync duplication. And also the functionality you have seen so far for analog input is also available here, like loop monitoring. So there are open and short, say, information in case of open short circuit. Massimo?
Okay, also in this case, also in case of analog output, let's see how a line or load fault is managed. In this case, it's the barrier itself, in addition to limiting the current and voltage towards the field to non-dangerous level, that carry out a real diagnosis of the loop towards the hazardous area. In fact, the internal circuit of the barrier is designed to provide us with a fault signal when very precise thresholds are exceeded. But how is this fault reported to the system? There are 2 ways. The first involves the use of a fault contact which is opened when the fault is detected and sent to a digital input card of a dedicated to the DCS system. In addition, a LED on the barrier, typically red color, is turned on. The second method is the mirroring of the fault directly to the analog output card of the PLC. If the PLC is compatible with this system and the supervised analog output card is able to detect a change in impedance at its input, the system guarantees considerable saving in terms of cost, as it supervises the loop without the need to add a dedicated DCS system for this purpose.
Okay.
Now,
Yeah.
okay, now let's see how it's possible to manage a redundancy system for analog output type application. In this specific application, the management of the 2 420 milliamp signal towards the dangerous area is not a simple solution, as the two signals should be mixed or added in some way. GMI has developed a redundancy system through a special termination board, which takes the two signals coming from two analog output cards of two different PLC and mixes them through its own precise logic. In fact, when we have a main common signal called master and a support of it, a common called slave, the two signals arrive at the terminals of the termination board and at the input of an electronic switch placed on board it. If both signals are regular, the master commands the loop and drive our load in the field. When this master signal fails due to a line fault or because the relative analog output card fails, the current signal relative to it goes to zero and the electronic switch placed on the termination board switches to the slave signal, making ensure that the output load continues to be correctly powered. When the master signal is restored, the electronic switch on the termination board switches back to the master signal. Through this switching logic, it's possible to carry out redundancy also for analog output circuits. We can say that there are two different concepts for the use of redundancy. The one that looks at the safety of the process and the one that looks at the availability to the process. The two philosophies of redundancy are in contrast with each other, and the end user must choose which way to go. GMI's our analog output redundancy satisfy the concept of process availability, allowing our plan to continue its work even if one of the components in the field fails. GMI's solution tries to simplify the redundancy logic to try to obtain the best possible result. Well, Andrea, we can
Yeah,
with it.
there is one question, Massimo,
Yeah.
which is, I think, important for everybody. So coming back to this slide, so we say that we have two methods. Like one is the mirroring, so the high impedance is reflected to the DCS or the PLC, and the other is the contact out. And the case, one of our attendees asked if he has to use both, and of course the answer is not. It's just an option. Of course, if the PLC support the mirroring functionality, so it can detect this difference in impedance, it can just use the mirror and not the contact out. It's an option we offer now.
Andrea, there is no problem to use both, I think.
Okay, yes, of course. But that is not mandatory.
Yeah.
Okay, so digital input, we have a solution CH2 SIL3 for proximity sensor and switch. There are, of course, with the proximity, you can detect the fault, with the contact not, but you can use, of course, the resistance in order to simulate the fault proximity. There is a full loop monitoring also in this case, and alarm out and duplication. This is the solution with duplication. So you can use the dual channel module and you can connect the sensor here. Why the output is reflected on the first input and on the second, first output and second output for duplication. Or you can use the first input as a retransmission and the second as a alarm of. We have a solution like this case modules that supports a proximity repeater with different level of course current for simulating the fault. But what we wanna show you is better this and the next one also regarding the modules that are offering 8 digital input with different possibilities. So you can transmit a one-to-one the channel. You can have also full metrics with the logical function that are configurable via PC. And also in this case, you have full loop monitor like eigenpedance and for open and short circuit. Maybe this part is your part, Massimo, because it's dedicated to the what we offer in case of line fault detection. What is important to know?
Yes, we focus on two particular digital input models that the GMI has developed, SIL2 and SIL3, able to transparently transferring the status of an Amour sensor or a contact in the field to a supervised digital input card of a PLC. This allows our safety system to know exactly the state of the loop in the field. Furthermore, this transparency makes it possible not to use a dedicated DCS system for detecting a fault, as in case of using a normal digital barrier, which needs to interpret it to contacts to understand the state of the input loop. But how does this transparency work? Well, through a network of resistors connected to transistor, the barrier output is able to provide the exact state of our input. According to the logic status of the input, 1 or 0, the device output sends a different impedance value to the PLC. In this way, the PLC, if correctly set, can recognize the status of the contact in the field. But what happened in the event of a fault detected in the field? In the event of a fault in the field, whether it's a short circuit or an open circuit, the transistor in series with the output loop opens, and an high impedance is shown towards the PLC digital input card, which is read by the PLC as a bad signal or a fault. This network of resistors at the barrier outputs allow us to obtain a mirroring system of a fault towards the PLC. Let's see now some particular application involving digital input isolator. The typical application is where we have to isolate a voltage-free contact or an Amour sensor in the field. And in this case, we use the classic digital input barrier or an isolator. But what happened in the field? We have a voltage and we have to signal to our system the presence or absence of this voltage. In this case, a standard digital input device cannot be used because its input front end is not available to accept external voltages from the field. In this case, we should use a digital output relay. That is a device that, depending on the voltage that arrives at its command, activate or deactivates an output contact and communicate to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate two PLC DCS systems placed in two different contexts. The digital output card of one of the two systems control our digital output relay, while the digital input card receives the contact state of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? First of all, we have to keep in mind that usually a relay is designed to switch important value of current, while usually towards a digital input system, the currents in play are very low, typically less than 100 milliamp. In this situation, we can face problem of oxidation of the relay contacts. Therefore, it is essential to choose a safety relay with golden play contacts, which consent a switching thanks to its high conductive performance, even current lower than 10 milliamps. To deal with this problem, GMI has equipped most of the relay of the new D5000 series with gold plate contact to make them available to this particular application. In addition, GMI has developed a universal device able to receive at its input different voltage level, for example, 24 volt DC, 48 volt DC, 110 volt DC, and so on, selectable via the switch, while the output provides a free voltage contact optocoupled type compatible with all PLC-DCST system, which ensure maximum conductivity even at lower currents. We are often asked how to monitor a wet contact which is in the field. Of course, diagnosing a wet contact in the field is difficult. And how it's possible to understand and differentiate the closed status of a contact from a short circuit. And again, how can we distinguish between the open state of the contact and an open circuit fault? This condition makes us think that the diagnosing wet contact from voltage in the field is impossible, but GMIs, through one of its analog devices, study a possible solution to overcome this type of problem and be able to provide diagnostic of a wet contact in the field. In fact, using a trip amplifier and connecting it with a network of resistors to the contact in the field, we can obtain voltage level at the input of the devices that allow us to discriminate one state from another. Furthermore, by programming our trip amplifier with interpretation threshold, we can provide the PLC with a different state for each condition of the input contacts, being able to diagnose the normal operating state of the contact from a fault state. Well, Andrea, we can go with the digital output application.
Okay, fine. Thank you, Massimo. So, solution for digital output, loop powered through the control signal, CL3, and also you can have different, you can have single dual channel as well, and possibility of have different outputs based on power required through the valve, which is connected with. We have a solution with line monitoring also, so that the first one we have seen so far is not with line monitoring, but this digital output is with the line monitoring and with external power. And of course, there are different, also in this case, different, you see 1, 2, and 3 output for different valve requiring different currents. And the loop power monitoring is open for open and short circuit. Also in this case, CL3 certification. There are also possibility of having solution multiple channel with very high functionality with the Modbus output, with the configuration over PC and different output selectable. You see here all the possibility for the outputs. Massimo, we explained a bit about how it works,
yes,
line monitoring.
Okay, quickly also for the digital output modules, GMI offers model which onboard line and load diagnostic to monitor loops in hazardous area. The models D5040AS loop powered and D5049S bus powered, based on the impedance of the load in the field, are able to check the health of the loop and in the event of a fault, generate a signal to the PLC directly to the digital output card, or through the classic voltage-free contact to a dedicated DCS digital input card. Of course, the D5040AS, being a loop-powered barrier for normally energized loads, is capable of monitoring the impedance of the inputs loop when the load is on. If it sees an impedance below 50 ohms, it detects a short circuit fault, and on the PLC side is transferred the information directly to the digital output card, showing an high impedance which translates into a loop current of less than 2 milliamps. When the impedance of the load on the other end exceeds 10 kilo ohm, the barrier sees an open circuit fault, and in the same way as before, show as an high impedance to the digital output card of the PLC. The signaling fault can also occur through a voltage-free contact to be acquired through a dedicated DCS system, or through a full LED placed on the front of the barrier. In the same way, the D5049S, being bus-powered, provides a complete diagnostic towards the field in both conditions, when the load is on and when the load is off. Also, like the D5040AS, it can transfer the fault information directly to the digital output card of the PLC with an high impedance variation, or through a voltage-free contact to be acquired with the digital input card of the DCS dedicated to the purpose. Let's now take a look at the redundancy problem also for intrinsically safe digital output application. Basically, there are 3 ways to obtain the redundancy of this system, with 3 different levels of redundancy. The first redundancy system involves all the elements that make up the loop, from the valve in the field to the intrinsically safe barrier to the PLC card that controls the loop. This is certainly the most effective and safest redundancy system, but also the most expensive, as to create the redundancy of all elements of the loop has considerable cost. The intermediate way would be to redundant all the devices except the final element, that is the valve. This means having 2 barriers and 2 cards controlling the loop. The main problem that arises in this case is that the redundancy up to the barrier forces us to mix the output signal to the barriers. This is feasible from the theoretical point of view, but first of all, it involves a derating of the intrinsically safe loop from AXIA to AXIB, which means that the final element cannot be installed in zone 0, but only in zone 1. And also involves the difficulty to find a final element compatible with the safety parameters that are added, having to put the output of the 2 intrinsically safe barriers in parallel. This is certainly the most complex method to implement. Instead, the simple and cost-effective way is the one proposed in the slide, where redundancy is obtained up to the digital output card of the PLC. After that, through 2 diodes, we mix the common signal coming from the 2 digital outputs at the input of the single barrier that guides our final element. This is the simplest system, as by not performing operations that add currents in the hazardous area. There are no problem in terms of compatibility with the final elements, and moreover, it's certainly the cost-effective solution as the redundancy of the device reaches the PLCs only. In the next slide, we encountered a digital output application where we were asked to be able to control a final element, typically a valve, by controlling it with the two digital output cards. The final elements, normally energized, must be de-energized only if both digital outputs give the switch off command. This solution studied to obtain an high availability to the process and to keep the plant always active in order not to have losses in terms of production cost, can be obtained through a double channel seal-free relay with the output contacts placed in parallel. In fact, in this way, the load will be de-energized only if both digital outputs give the shutdown command. Of course, this solution is to the disadvantages of safety, as putting the output constant of the seal-free relay in parallel leads to an increase in possible dangerous failures. But thanks to the GMI relay, we are still able to maintain a seal-2 level of the application and to obtain a high process availability. A different application where we were asked to create a high safety loop where the final element was de-energized when only one of the two digital outputs send the shutdown commands. In this case, always using the same double channel seal-free relay, the desired safety function can be obtained by placing the relay output contacts in series. In this way, the seal-free level of the loop is increased to obtain the required function. This application makes us understand that sometimes it's possible to increase the safety or the availability to the process by combining low-cost but very smart solutions, such as those proposed by GMI.
Okay, well, great, Massimo. Just one highlighted that this is for non-IS application, while the previous one, like this one, is for IS application.
Yes, of course.
You see the differentiation by the color. Okay, great. So we go through temperature. We have a solution with the temperature where you can connect thermocouple, RTD, potentiometer, 2, 3, and 4 wide, depending on the sensor. Those are, let's say, converter for IS application, analog out with the source and sink, and the line monitor like burnout. You remember the burnout function was one of the features required in general. So because maybe you can get trouble on the sensor input. So there are also isolators that isolate and they do not convert, but just transmit one-to-one the sensor, in this case for resistance, like RTDs or potentiometer also. They can repeat really one-to-one in a safe manner to the PLC the input for, of course, a hazardous application. There are also solutions for thermocouple. So thermocouple can be repeated one-to-one. There are solutions with alarm. So those are small, say, PLCs that control the input and retransmit the 4 to 20. They convert the signal, temperature signal in 4 to 20, while they have also 2 alarm output for free configurable as different possibilities like high alarm, low alarm, with there are different that can be retrieved by the configuration, the PC, the software PC based configuration. You want to say something, Massimo, about the software functionalities?
Yes, a few words about the configuration software of the D5000 series barriers. Through this isolator, through this software, it's possible to configure and read all the parameters related to our devices and variables in the field. save and reload data and configuration in a local hard drive, monitor the variables in the field in real time to verify the correct functioning of the loop, and finally record the monitoring session and save them in a file. The software is free and downloadable from our website and absolutely compatible with all Microsoft Windows systems. In the slide, we see the configuration windows of our D5072S temperature converter, where it's possible, for example, to configure the type of input sensor, including thermocouples, RTD, potentiometer, or signal in millivolt. The output parameters are fully user configurable, and the possibility of creating a custom table is also available, where for specific applications, the customer can create a table of input value for particular sensors, such as PTC, for example. And again, the monitoring session, where it's possible to check the parameters of the input variables and the health of the loop in real time. All our D5000 series devices can be configured with this software to perform their main function or to obtain special function. Well, Andrea.
Okay, fine. Let's go to other application like weighing. We have a solution for load cells. So for measuring maybe the weight of some tanks or some loads, so you can connect it to these barriers, isolators for. So we have a solution like a load cell to milliamp, a load cell just a repeater, PC configurable with Modbus output and field, of course, calibration. There are solutions for vibration when you wanna collect some vibration sensor, accelerometer, and for say mostly for vibration monitoring, of course, systems. And here we have an application, Massimo.
Yes, of course. Particular applications are those involving devices such as accelerometers or vibration sensor. When the accelerometer operates in a classified area, they must be isolated through an intrinsically safe barrier. As in the slide, the D5062S isolates this particular type of sensor transparently, providing the reading system placing the safe area with the waveform on the same level and frequency as the generated by the sensor, so that the system can read the signal correctly. It provides a fully floating DC supply for energizing vibration transducer, accelerometers, or 2-3 wire sensor located in a hazardous area, and repeats the sensor input voltage in a totally isolated circuit located in safe area to drive vibration monitors or analyzer for rotating machinery control and supervision purpose. GMI can supply devices to isolate and power their different type of sensor present in industrial automation and beyond.
Okay, fine. Okay, we have another poll. You don't mind? No, sorry, we don't have it. This one we skip it because it maybe it's too late. We want to go through directly to the Modbus interface, which is one of the standard we have. Just a few words, Massimo, not too many.
Yes, of course. Many of our devices use Modbus to communicate. But what is Modbus? Modbus is a serial communication protocol that connects probe logic controls. It has become a standard in industrial communication and is currently one of the most popular connection protocols in the world among industrial electronic devices. Modbus allows communication between different devices connected to the same network. For example, a system that measures temperature and humidity and communicates the result to a computer. Modbus is often used to connect supervisor computer with a remote terminal unit in a supervisor control and that I can say about this. Modbus RTU is accepted due to its ease of use and reliability. Up to 127 modules can be arranged in a multi-drop network and monitored and configured by a single master unit, as shown in the following picture. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and when the request makes available its value for reading and writing. Complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a Modbus master is available on the system side. And we also say that what are the advantages of using Modbus communication? With a single Modbus RS485 interface, is possible to connect and communicate with all the devices present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarm. This allows us to have significant saving in terms of cost. And again, real-time information on the type of alarm and on the health of the load and the line. It's also possible through Modbus a complete remote programming of the devices. In the next slide, we can see what are the Modbus devices in GMI portfolio. For all products category, GMI provides devices that can communicate Modbus and be programmed through Modbus. In the next slide, we examine an application where a sensor installed in a hazardous area must communicate via RS485 with the control unit located in a safe area. This sensor located in a hazardous area must be isolated and powered through two barriers. One barrier will supply power to the classified area so that the sensor is protected and cannot generate spark that can cause an explosion. The other barrier will have to provide isolation of the RS485 bus line so that it can connect with the unit control. The advantage of using this specific connection is the possibility of connecting up to 32 devices in multi-drop mode on a single bus, which allows us to form an integrated network of devices with considerable saving on installation cost. When installing a device with the bus interface in a hazardous area, there are two ES barriers that need to be installed: a power barrier and a signal barrier. The signal and the power are two separate ES circuits, so they must comply with the proper ES segregation distance. The D1061 field bus isolation repeater provides proper isolation and driving of an RS485 intrinsically safe line located in a hazardous area or hazardous location, communicating with the RS485 line located in a safe area, non-hazardous location. The unit provides the line termination capability on board hazardous and safe site.
Okay, thank you, Massimo. So now we came to the conclusion of this webinar, just to compare and give you extra information. So different among the most widely used protection methods. So we say that intrinsically safety explosion-proof and purging pressurization are the most common. And we say that for safety, flexibility, installation cost, and maintenance cost, so intrinsically safety is very safe, very flexible. Installation cost is lower, and maintenance cost is lower. Of course, cannot be used everywhere on any sensor, because, for instance, for application in the motor with high currents, that is definitely not possible. But when you have sensor, you have a low power consumption, 24 volt and so on, that is, if it's possible, is definitely the most interesting solution. is very safe, and also installation maintenance cost is interesting. Of course, maintenance cost, if you use Zener barriers, is something you have to keep where you have to keep attention, because it's a high maintenance cost. You have to check ground and so on regularly. For intrinsic safety, for isolator is of course is bad. We want to say also something more, that the intrinsic safety is interesting because it allows the live maintenance. It's the only one, the only technology that allows the live maintenance, so without disconnecting physically, and open the system, open enclosure and so on. So we say that entity concept against the system concept. So an isolator barrier is not sufficient for reaching the safety. So as we say before, the system loop must be verified or certified in the entire system. So isolator barrier certification compliance must with the area classification. So depending if the isolator you are using is suitable for the application you wanna use it for. The field device certification complies with the area classification. So the safety parameter of the apparatus must match. Okay, so when you connect the barriers with a sensor, the parameter must match. You have to take into account also the cables that are using with, and also the max temperature compliance with the RS classification. Then, here an example, barriers with a sensor. So you have some safety parameters, and this from both sides, in this case, from the barriers and the transmitters, like current, voltage, current, power, capacitance, inductance. So those must comply with. I don't want to tell you much more, but if you're using GMI, of course, we have a website. We have a tool that give you all the possibility for checking and check if the barriers you're using, the model you're using, is compliant with the set. So just fill in few parameters into this form, and you get an answer. You get also a report. What else? So Zener against isolated barriers. Of course, the barriers, the pure Zener barriers, low in cost, simple design, low power, have some voltage loop issues, of course, low resilience to wiring mistake, field device isolation require dedicated hard connection. Wire isolated barriers can be, of course, more expensive because the hardware is more complicated, it's bigger, it's bus power, has constant field voltage, short circuit and reverse polarity proof, that is very important, can be used with ground sensors, okay, and no require hard connection. That is also very important because the hard connection requires continuous maintenance. We finish. Sorry, we exceed the time, 1 hour, so it's very difficult for us to keep everything on time, but all details you can find on our website, like such documentation and product details, certification, use of software, and so on. Thank you. We have also live webinars. On our website, you can find the next webinars we'll held as a GMI, not only with Massimo and I, but other people regarding the functional safety, ethics, rules, different aspects, very interesting with very professional people. You can see this webinar. You can have the recorded version in live, so in our YouTube channel by tomorrow, I guess, but all the other are right there, so you can have a look, you can watch again. Then we have the last poll. Thank you if you want to answer how we did. Where it is, let me launch it. We appreciate your, of course, support, and of course, also no name here. You can say whatever you like. If you like it, if you didn't like it, if it was poor, of course, not in line with expectation. That is also something that's very difficult also for us. Let's match the expectation, customer expectation. Okay, well, of course, we have a more also topic in future. We'll try to enrich what is our, say, libraries. And we hope to see you again soon. Thank you for answering. I want to stop it now and leave you to your, let's say, to your things. Thank you for today. We just remind you our name, emails, and picture. If you want to answer, write us. We are, say, of course, available for any question. Thank you.
Thank you, Andrea, and thank you to all our attendees. See you the next webinar.
Thank you very much.